All right, so we're going to finish up with section 12.1 on finding limits. And this part of the notes, you're actually going to need to get the PDF that I've put in Google Classroom for finding limits on your TI nSpire. And this is all has to do with when you cannot calculate the limit algebraically by simplifying or factoring. So you're going to have to use your calculator when you cannot algebraically do something. So I went ahead and I've written out all of the steps that you're going to have to go through, and I'm going to walk you through some examples. So starting off is you're going to have to go to a graph page. So you're going to enter the function on a graph page. So we'll do that in a second. And then I recommend doing a split screen because you're going to want to have a table next to your graph to help you. And so I'll walk you through how to do that. We're going to be editing the table settings. So for the table start, we're going to be looking at the x value the limit is approaching. So when we do this one down here, number 1, we're going to start it at 0 because the limit is approaching 0. And then we're going to change the step of the table by the increments we're going by. And we're trying to get as close to that value as we can by changing it by such a small amount. Notice how I have 5 zeros here. So you're going to do 0.00001. Get as close to that starting value as you can. So then the next task is to just scroll up and down. So you're going to scroll up and down and you're going to look for one of these 4 things. If all the values in the table near that starting point is the same, the limit is whatever that value is. If they keep getting larger, the limit is infinity. If they keep getting smaller, the limit's negative infinity. And if the table just kind of oscillates between various numbers, it doesn't look like it's like approaching a single number, we're going to say the limit does not exist. So I'm going to walk you through all of these things. You have these as reference for this first example that I have right here. So right now, if you try to use just algebra to find the limit, you notice that it starts at 0. You're going to go ahead and plug in 0. So you get 0 squared plus 9 minus 3 all over 0 squared. And so you get the square root of 9 minus 3 all over 0. Or basically you get 3 minus 3 over 0, or you get 0 over 0. So right now, algebraically, there's nothing that we can do, or we don't have a method at this point to simplify things algebraically. So what we would do is we want to be like, okay, well, what does that mean? Is it undefined? Is there a limit? What is the graph telling us? So that's where we're going to go to the calculator to see if the limit does exist. So you're going to open up the TI nSpire. I already have the graph in there. What I went to is I went to add and I went to graphs. So you're going to do that same thing. And then what you'll do is you'll type in the function that you're trying to take the limit of. So in this case, here's what the graph is looking like. And we want to figure out how it behaves around 0. So if we were to kind of zoom in, we want to see what the graph, as we approach 0 from the left and from the right, it looks like it's approaching a certain value. So what I told you to do is I said go to the table. So you're going to go to table and you're going to go to a split screen. And you're going to see what the values are behaving or looking like around 0. So you're going to need to edit that table. So I went to menu and I went to table and I'm going to edit the table settings. And so I'm going to start it at 0. And then right now my table step is going by 1s. Remember, I want to get as close to 0 as I possibly can. That's where I said do 5 zeros and then a 1 to have it change by really small increments. So now if you notice, I'm going starting at 0 and going by really small values. Now as I scroll up and down on the table, that's what I told you to do, is scroll up and down. And if you look at the very top, this gray bar at the very top of the window, you can see all the values are similar. They're around like 0.166. And you can, if I scroll into the positive directions, it's kind of the same thing. Notice how they're all hovering around that same value. And if you look at the graph on the left, you can definitely see, yeah, that's about, they're looking like they are approaching when it's around 0.166. So this one actually does have a limit. So if we go ahead and write this down, we would say the limit is equal to 0.16 by looking at the graph. And it looks like it's 0.166, so I'll just have that. All right, so that's how, without having to do any algebra, factoring, or simplifying, we would use the calculator. So we're going to go ahead and try the second one. So here, So algebra, simplifying that, trying to see what the thing would actually be, we're going to have a hard time. So this is where we're going to go to the calculator and type that in. So going back, this time I'm going to go to the second one. This is what the graph looks like. Now, remember, we're trying to figure out what it's behaving like around 0. Just by looking at the graph, you can see in one direction it's 1, and the other directions it's -1. And if you were to go back to that table, do a split screen, and we're trying to figure out how it's behaving. You can see it from the graph, but if you wanted to get some practice going to the table and editing the table settings, we're starting it at 0, getting as close to it as we possibly can. So we're going by 0.0001. And then if you'll notice, on one side it's 1, on the other side it's -1. They have to be approaching the same value for the limit to exist. If they are not, it does not exist. So in this case, because of just what the graph looks like, you could have not even gone to the table. You would have just said, all right, the limit does not exist. And the main reason is from one side it was 1, the other side it was -1. It wasn't approaching the same value for at 0. All right, number 3, if I try to plug in 0 in here, I get the same deal. I get 1/0², which is undefined. So that means I'm going to have to go to the graph to see what's going on here. I want to see if I ever get 0/0 or I get something that's undefined, you've got to go to the calculator. So I'm going to type that in, go back to a new graph page. I think I already have it in here to save us time. So here it is, there's 1/x². Now, if you look at this, you can see that both graphs, if I look at how it's behaving around 0, I'll actually screenshot it so I can write on this. Whoops, screenshot this. If you look at this, both graphs, as you're approaching 0, this one's getting bigger, and then this one's also getting bigger. They're both going to positive infinity. If you want to check out the table, you'll see that the graphs are actually or the tables in the value are actually getting bigger. So I'm going to delete this screenshot. I'll go ahead and add in a table split screen so we can see it. I'm going to edit the table settings, and this time I was starting at 0. I'm going to change it again. I want to see how it's behaving really close to 0, so I'm changing it by a really small increment. And these are huge numbers. So the numbers are just actually getting bigger and bigger. So that's why we would say that the limit of this graph would actually be positive infinity. Okay, moving on. So this one, you want to see if you plug in 2. It looks like I could actually plug in 2 algebraically. Oh, it looks like the denominator is going to be 2 minus 2 squared, or I'm going to get 0 squared. We're going to have a problem right there. So I have -1/0. That's undefined, so I've got to go to the calculator. So once you go to the calculator, you can actually just look at the graph if you don't want to have to go to the table. Let's see, I think I already have it done here. Typed it in, and you'll notice if I look at the graph, if I screenshot this and I draw on it, you can see as I'm approaching 2, remember we were looking at the limit, how it behaved around 2? You can see that this graph, as I'm approaching 2, the graph is going negative, and as it's approaching 2 from this direction, it's also going negative. And this graph keeps continuing. So this one, without even looking at the table, I would say that the actual limit of this function would be -infinity. And last but not least, you can check out this graph. Algebraically, you'd have to find sine of pi/0, which is undefined. So we have to look at the graph once again. So you can go back to your graphs, type it in, and you can see what's happening. One of the things that I put is you're seeing this sine graph, and I'll screenshot this one so you can see my pen move along this graph, is as I'm approaching 0, I'm looking at how this is behaving around 0. Notice how it's oscillating. It's going up and down from each direction. If you were to look at the table to talk about kind of that oscillating effect, if I go to the table and the split screen table and I edit the table settings, I'm going to start it at 0, get as close to it as I possibly can. And then when I do that, you'll notice that these values kind of oscillate up and down. It doesn't really approach anything. All those values aren't the same as like that first example that we did. And you can kind of see that represented on the graph. So this would be yet another example of where the limit does not exist. Main reason is around 0, this thing is just going up and down and it's not really approaching any type of particular x value. All right, or y value. So in this case, that's it. That's finding limits using your TI nSpire. Thanks, everybody.